6.2 is the law of cosines, and again, we're dealing with oblique triangles, things that don't have a 90-degree angle, so we need other formulas. You're going to find that only the law of cosines works with side, 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 and sine angle side. So the law of sines works with things like angle, angle, side, or angle, side, angle, and once in a while with side, side angle. This is handled by the law of cosines. So we have what we call the standard forms over here. And it's not that there are three different. It's just if you are looking for A, you use B and C, B and C. If you're looking for B, you use A and C, A and C. So you'll see how I write it out. I just do the two sides. Now, the alternative form is for speed. You can actually solve by taking this over and then dividing this stuff off and then inverse cosine. You can find angles with the standard form, but the alternative form is for speeding up the process. And what you'll notice is that if you're looking for angle A, side A gets subtracted up top. So you could try this, solve one of these for the cosine and see what it looks like. Basically, then all they do is take the negative sign and put it up top. So not a big deal. I would memorize the two formulas, though. It'll speed things up when you take the test. So if we're supposed to find side A, I would say A, and I even go as far to do the square root. I don't, like up here, I don't leave it as c squared and I do it later. I just do it right away. So A will be 9 squared plus 12 squared minus 2 times 9 times 12 times the cosine of 25. And this allows me then to just go right to the calculator. Again, we're in degree mode, and I can just hit square root right away. Square root of 9 squared plus my 12 squared minus 2 times 9 times 12 cosine of 25. And I'm getting 5, so A is about 5.4. So that's how you find the side of a triangle. What if I want to find measures of angles? So if I want to find measures of angles, I would use the alternative. Now, one of the things I do suggest is that you find the biggest first, because then you don't have to worry about that ambiguous case back on the law of sines. After this, you could do law of sines because there can only be one obtuse angle. So anyway, the biggest angle will be B because it's opposite the biggest side. So I do B equals the cosine inverse right away. If you don't do it this way, you have to find the number and then hit second cosine anyway, so not a big deal. But what it's going to look like is I would do my 8 squared here plus 14 squared here minus the 19 squared. Remember, the partner side gets subtracted. And then on the bottom, it's 2 times 8 times 14. Now, if you have trouble typing this in, you might want to do the top and the bottom. But I'm going to put parentheses around the top, then parentheses around the bottom. So be careful. Watch how I do this. I'm going to clear that out so there's only one thing. I'm going to hit second cosine right away. I'm going to put another parentheses. Now I'm going to type the top in. That's 8 squared plus 14 squared minus the 19 squared. Now I'm going to close the top. So notice the top is also in its own parentheses. Divide by. The bottom is 2 times 8 times 14. And again, close the bottom, technically close the whole cosine inverse, and I get 116.8. So that's angle B. Now, to find the other two sides, you can do law of sines or the law of cosines again. It's law of cosines day, so I'm just going to do the formula again. So I would find angle C next, I guess. Let's do angle C. That'll be the cosine inverse. And again, if you want to pause the video and try to write the formula and then come back, do so. But I'm going to do C, so that will be the 8 squared and the 19 squared. But the 14 is the one that's being subtracted because that's the partner side. And then on the bottom, 2 times 8 times 19. So the partner side only gets used once, and it gets subtracted. So again, I can hit second cosine. I'm going to put another parentheses in, and I'm going to do 8 squared plus the 19 squared minus 14, that's the partner squared. Technically close it. Divide by, open another one. Now this is the bottom, so you go 2 times 8 times 19. Technically close it, and this is 41.12. So if you add your two angles together, 41.12, and I can add to it 116.8, and then if I do 180 minus that answer, .08, I guess. So this would be angle A. It was 180 minus 116.8 and the 41.12. All right, so if I'm supposed to solve the triangle, I would draw a triangle, probably label A, B, C. A would be 75, little b is 12, C is 10. So we have side, angle, side here. That means I can find little a first, and I would do little a as the square root. And I go 10 squared plus 12 squared minus 2 times 10 times 12 cosine of 75. Throw that into the calculator. So if I was going to throw that into the calculator, I do 10 squared plus 12 squared. So 10 squared plus 12 squared minus 2 times 10 times 12. Oops. Sorry. So 12 and then cosine 75. So I'm getting about 13.49. So that little side A is 13.49. Now you have all three sides of the triangle, and again, it's law of cosines day. So I do know that if this is 13.49, I could do law of sines with those two angles. So if you like law of sines, go ahead and finish with law of sines. But it's law of cosines day. So now I would go ahead and find angle B. It is possible that this angle could be slightly more than 90, and law of sines can't find it because it's a slight possibility that it's obtuse. let's do the law of cosines to find that. So law of cosines would be angle B equals cosine inverse. And again, on the top, you go 10 and your 13.49 squared, and the partner side gets subtracted. And I misspoke earlier because if 13.49 is the biggest side, 75 is the biggest angle, then I can't have any more obtuse angle, or I couldn't have an obtuse angle because angle B has to be smaller than 75. So law of sines would have been fine. Now you go 2 times the other two sides again. So you do the 10 and that 13.49. So that's tricky if you're using the one that didn't work. So plug that into your calculator and see what you get. All right, so angle B, 59.24 degrees is what you should have gotten on the calculator. And then the final angle is just 180 minus the sum of those two. And so we got 13.49 for the side, 59.24 for that angle, and when you add those answers together and subtract from 180, this is your missing angle. All right, example 4 is a DIY, so find the smallest angle of the triangle and come back and check your answer. Pause the video now. All right, here's the DIY that you're working on. You just put 9, 12, 14. So if I ask you to find the smallest angle, in this case, it's going to be angle A because it's opposite the smallest side. So if you do angle A, maybe you do the top and the bottom, and you get this decimal second cosine of it, you should get 39.57 degrees. All right, example 5. It's an okay problem, but you have to understand a little bit about softball fields, baseball fields. So if the pitcher's pitching from 43 feet and the distance between the bases is 60, you can kind of draw your diagram out. But remember, this is they call it a softball field, baseball diamond, but it's a square. And so what's happening is you have a right angle down here, and this is a bisector. So when it comes through home plate, it bisects it into this 45-degree angle. So the pitcher's mound is not exactly in the center of the field. So how far is it from first base? This is what they want you to find. So H would be equal to the square root of 43 squared plus 60 squared minus 2 times 43 times 60 cosine of 45 degrees. And just go right to your calculator and plug that in. So remember, I take the square root right away. Take the square root right away, but you should get 42.43 degrees. All right, so this example is set up a little different. Sometimes they get a little tricky with what they're doing, and they might ask you, you know, how far is this side? And they'll say that the ship is traveling, and when it gets to this point, it goes, you know, like left 30 degrees or something. And so this angle is 30, which means this angle is 150 because you turn to the left 30 degrees or something. That's kind of what they normally do to trick you. But in this case, basically you're looking at this dotted line triangle, and you know all three sides. So I would start by finding angle B and then go from there. You can use law of sines or law of cosines, but find all three angles and then come back and check your answers. So pause the video now. So here are the answers we were getting. Angle A is 7.92. Angle B, the obtuse one over here, biggest side, 139, so it should be biggest angle. That's 166.15, and C is about 5.93. So hopefully those were the answers you got. All right, here's one of the coolest formulas, really, and for sure, we had the oblique triangle, which was used for side angle side in the law of sines. Just a reminder, if you had side angle side, you could find the area by doing 1/2 a side times the sine of the angle, the included angle. And now this one is for side, side, side. So if you know all three sides, you're going to add up your three sides and divide by 2. Be very careful. A lot of students do this, and they get it wrong because they didn't put parentheses around the three sides. So either hit enter before you divide by 2 or put it in parentheses. And then you just put an S in there, and you really can't mess that up because if you subtract in the wrong order, you get 3 negative signs, and 3 negative signs under a radical won't work. So just pay attention to that form, but memorize this before the exam. So we can go ahead and find S by taking 53 plus 43 plus 72 and divide by 2. So go to the calculator and add those up. So let's go ahead and clear out. So 53 plus 43 plus 72. So like I said, maybe hit enter before you divide by 2. And so we're getting 84. And then the area formula is to simply take that 84, and then you do 84 minus 53, 84 minus 43, and 84 minus 72. Now in this case, these aren't too bad of numbers, so it might be easier just to do 84, and this would be times 31, and this would be times 41, and this would be times 12. It's a little easier than typing in all of those parentheses, but we do the square root of 84 times 31 times 41 times 12. And I'm getting 1131.89 meters squared. All right, try this DIY, special triangle, use Heron's formula. Pause the video now. Okay, so now when you do the 11 plus 16 plus 24, hit enter, divide by 2. Now this number is not so nice, and I don't know that I would trust my mental math, subtracting with halves and whatnot. So this time I definitely would do the square root and put the 25.5, the S value, and then parentheses, 25.5 minus the side, 25.5 minus the second side, 25.5 minus the third side. Close each one of those, and you should get this answer. And that's a pretty quick formula. So you have 2 good formulas for finding the area. They'll help you on the test.